All right. So I'm just going to like imagine a hypothetical corporate environment here, and we'll talk about how we would detect attacks on this corporate environment. So I want you to imagine here we've got this is Foo Corp, and they run some web server, and it has some service there, and you can access a particular page and pass in some parameters, and it'll run a program on that web server and learn some stuff. Okay. So I want to talk about a couple of different approaches that you could use that the company could use to try to detect attacks on their network on that server. One approach is called network intrusion detection. Looks at the network traffic, monitors all of the packets that are, let's say, going from the outside internet into the inside network, to scan them to look for attack traffic, things that might be attacks on that web server. Okay, so since we're worried about attacks on a web server, we might look at the HTTP requests, look at all the TCP connections that are to port 80 to that particular web server. And then we might look in the requests, we might parse the requests and look for things that look dangerous. Like this one was running a program with some parameter. So we might say, oh, maybe I would worry that if there's a bug in that program that maybe someone could try to download some secret file on the server, like the list of passwords or something else that's particularly critical. Password file is often a favorite for attackers to try to download if they got access to your file system, because then they can try to crack the hashed salted passwords and recover users' passwords, and then once they've got credentials, they've got a step further in their attack. So we could scan all of the traffic and look for any packet that contains the file name /etc password, because that's the file name where passwords are stored. Or we could look for .. That would be an example of a particular kind of attack that we'll see when we look at web security, called the path traversal attack. And it's common to see if there's a path traversal vulnerability in the service, then typically attacks will have to somehow use .. somewhere in their attack traffic. Okay, so these are kind of indicators that maybe someone's trying to attack us, and they should be hopefully rare and benign traffic. All right, so in that approach, the network intrusion detection system, called a NIDS, is sitting between the border router and the internal network, and it's monitoring all the traffic. Okay, so the benefit of this is great: centralized control, transparent. You can add it onto an existing corporate environment without having to modify end hosts. It's very easy to deploy. It's relatively cheap. You need one of these, and it protects all of your whole network and all your systems in it. So quite convenient. So let's look at some of the details about how this would work internally inside the network intrusion detection system, the NIDS. It might go something like this, where, let me back up a little bit. Maybe I can't back up. Okay. I want you to imagine that packets start arriving, and each box here is a packet, and each row corresponds to a connection. You can see that the packets may arrive in any order, and they're interspersed among all the connections. So what the NIDS is going to have to do is going to have to keep track of all the active connections and then reassemble the packets in the data stream for each connection. Map each packet to its connection, look at the sequence numbers to figure out what order to put them in, wait until you've seen a full request, and then once the NIDS has seen a full request, then it knows what's being requested. And it can then use its knowledge of the HTTP protocol to parse out that data and understand the meaning of it. So for instance, in the first connection, the green connection, we see this is an HTTP request for the URL /foobar. And we can see the red connection has an HTTP request for a different URL, and it has a HTTP parameter, which is like an argument for that request. And then the blue connection is a connection to the mail server. And if we were to keep parsing this, we could parse it and discover, oh, this is an attempt to send an email, and it's from this address, and it's to that address, and here's the text of the email. Okay, so that's how a NIDS is working. It's reassembling the connections and parsing the data in each connection using its understanding of the format of the protocol for that particular port number. Yeah, encrypted web traffic. So let me come back to that. This is very difficult for encrypted web traffic. So I'll mention that in a moment. So in general, the NIDS has a table of all active TCP connections and some state for each, like the data it's seen so far, or whether it's seen a partial match for etc password. This remind you of something we've seen before. This is very similar to how a stateful packet filter would work, which would also be doing reassembly. But now we're using it for detection. So instead of the stateful packet filter might block a connection if it sees something bad going on. Here, we're just focusing on detecting that there's an attack, and we haven't really specified what we're going to do if we detect an attack. I don't know. Maybe we'll page the system administrator, say, oh boy, there's a problem, or maybe we'll block the connection, or maybe we'll do something else. Okay, so what does the NIDS do when it sees a new packet that's not associated with any known connection? Then it creates a new connection. Maybe it's just starting up and it doesn't, hasn't seen the three-way handshake, so this is a pre-existing connection. Then it just adds it to its table. Okay, here's another connection I need to know about. And when it sees a packet that is associated with an existing connection, then it can, update its state for that connection. Okay, so this is a NIDS. There's also network monitoring tools that are not trying to detect attacks, but just parse the traffic and understand what's happening. But I'm going to focus on detection.